Hello, thank you for watching my talk. My name's Craig Buckler and today I'm discussing localization. That's building websites or apps that are accessible to everyone, no matter where they're from. Now, like many Brits, I'm complacent about English. I've never properly learned other languages. Sure, I've mastered the universal basics of ordering a beer, but like most I speak loudly and slowly while gesticulating wildly. And it's quite successful. I may not get exactly what I'm after, but I don't care after I've had a few drinks. But this doesn't translate well to the web. Our movements don't help. Now, I've tried using interpretive dance, but it's quite tough explaining to a non-English speaker that my container-based architecture course will help with dependency management when they're developing a web application in a local environment. I'm just not convinced that it gets the full message across. So this is the point of this talk. If you can internationalize your site, you can improve access by 700%. It's a bold claim, but I've got a full scientific proof. So we have this impression in the West that English is the most widely spoken language. And sure, there are 379 million people who speak English natively as their first language. But there are 917 million who speak native Mandarin Chinese. Another 460 million speak Spanish and 341 million speak Hindi. If you pick a random person on planet Earth, there's just a 1 in 7 chance that they'll understand English. So it stands to reason if you can internationalize your site or web app, then 7 times more people will understand it. You've improved access by 700%. Your market is 7 times larger, sales will increase 7-fold, and profits will increase accordingly. And that's science right there. Anyone who disputes it is just being pessimistic. But it's worth showing this to your boss or client if they ever express doubts over the cost of good web accessibility. Now, I have to admit, I'm not an internationalization expert. I've generally avoided it because of my complacency with English. And it's something few of us consider until it's the end of the project, and then it can be too late. And I won't be talking about document text today. Google Translate or Microsoft Translator are increasingly viable if you need to translate web articles. Older translation systems converted each word separately, so the context could be lost and sentences got mangled. But the modern translators use machine learning techniques, and they analyse key phrases so the results are much better. You may be able to use them if your text doesn't have too much of the way of unusual terminology. Bung a few quid at a student just to check it, and everyone's happy. So I'm mostly referring to web apps, and these should have less text so they're easier to localize. In fact, you could avoid text altogether and use icons or emoji to convey meaning. So if someone's rating your app, you'll know immediately what these images mean. And if you don't, you can just ask a passing 10-year-old. And you can also use icons to convey meaning and functionality. If you see this icon, you immediately understand what it does. That's right, you click it to justify text so it aligns with both the left and right margins. Now, be honest, you thought I was going to say it was a hamburger menu icon. And similarly, what does this icon do? Now, you probably understand it's used to save data. But I'm clearly in my early 20s and I've never seen such a bizarre looking object. And what about the vast majority of people in the developing world where the PC revolution didn't happen, but mobile phones reign supreme? My point is that you can't always rely on images or icons alone. The first internationalization option you can use is tokenization in your app's templates. So this HTML snippet has a couple of email tokens that are replaced before the user sees it. In English, we see email, but Turkish speakers see e-posta that's shown here. And you may have used getText, which takes tokenization to another level. Versions are available for most languages and runtimes, and it allows you to identify strings in your code which create language files that can be edited by an interpreter. And this replacement would typically occur server-side, but you could do it on the client too. And you could even use a static site generator such as Jekyll, Hugo or Eleventy to create localized versions of every page. However you do it, you need to check what language the user wants, and then pull in the appropriate language file to replace the tokens. Now, one option is to give users a language setting that's stored in your app's database. Or you could check the browser's HTTP accept language header, and that's sent on every request. But please don't set the language based on the user's physical location that you get from an IP address or a geolocation lookup. You cannot determine the language from a country. Many countries like Canada, Switzerland and India have multiple languages. Russia alone has 24. And the user could also be travelling, if we ever go back to that. And I'd rather your site's language didn't switch just because I happen to be using a proxy server based in the Cayman Islands for completely legitimate business purposes. Now, language tokenization helps if you consider it from the start of your project. It's more difficult to retrofit it into an existing app that your boss suddenly wants to offer in Korean. But this really is the start of your problems. We're quite used to seeing European languages, and they're superficially similar. If you consider a sign-up form in English, the Spanish, French and German equivalents look fairly straightforward. But it's not always this simple. First, there are variations of the same language. The Spanish spoken in Spain isn't identical to that spoken in South America. The Portuguese spoken in Brazil has diverged from that spoken in Portugal, and you'll probably need more translations than you expect. Plurals can also be tricky. In English, we add an S to the noun, but Polish has 7 different noun cases depending on the number. But you may be able to get around that with evasive techniques and avoid plural complications altogether. And then be wary that replaced words may be longer or shorter than in English. So this is email in Russian, and I have no idea how it's pronounced, and I'm not going to try. But your designer will need to reserve more than 30 pixels of space for the label. Then you've got to remember that text is not always written from left to right. Some is written from right to left, and others is written from top to bottom. Now, there are some newer CSS properties that can help with all this. They're beyond the scope of this talk, but they're all on MDN. Whether you can create a flexible UI that works in all directions is another matter. And this is going to terrify those designers who haven't yet accepted that browser viewports can have different sizes. So this localization lark is difficult. So let's avoid too many complications by sticking with English and maybe a few European languages. And let's also avoid text when we can and just show hard data. We're not going to achieve that 700% access improvement, but doubling or tripling profits should be possible. So let's update our app to show users their next billing date. In the UK and most of Europe, South America and Asia, we read this as the 12th of March 2024. But those in the US see it as the 3rd of December 2024 because they use that weird month, day, year format. And those in Canada, China, Japan and Hungary see the 24th of March 2012 because they're using a far more logical year, month, day format where the most significant digits come first. Okay, so let's show users their billing amount in 1,000 crypto cash units or whatever currency we're using. Now this is read as 1,000 in the US, UK, Canada, China and Japan. But those in Spain, France, Germany and Russia get the bargain price of 1 because the comma denotes the decimal fraction. Okay, so let's avoid all number punctuation and make an exercise app just for English-speaking users. And that'll show something like this. Now in the US, they'll see this as the equivalent of 6.2 miles or 93 quarts or whatever weird imperial measurements they're using today. Actually, did you know that only 3 countries in the world use imperial measurements? That's the US, Liberia and Myanmar, and that's it. Now admittedly in the UK we use metric and imperial interchangeably, but that's just to confuse the tourists. But going back to my point, in the UK, Canada and Australia, we read this as 10,000 measuring instruments because meters is spelt incorrectly. Now, admittedly, the context is clear here and we're quite used to seeing US spellings, but that's not always going to be the case. Now, in the past, I've just ignored these problems, but it can lead to confusion and increase your support costs. My point is that internationalization is difficult and it's possibly trickier than you first thought, but you don't have to avoid it. The JavaScript Intl API can resolve many of the common data formatting issues you might have had, but I'm guessing that few of you have heard about it, and even fewer of you have used it, or you wouldn't be here listening to me droning on. So the API can be used to localize dates and times, relative periods such as yesterday, tomorrow, and next week, numbers, currencies, percentages, and units, the names of languages, regions, scripts, and currencies, lists of items with localized equivalents of and or. It can help with plurals, and it can also handle localized string comparisons. And it's got excellent support. All modern browsers support 100% of the standard. And even IE 11 supports 93% of it. And that legacy browser, Safari, that on iOS has reached 96%. And you can use it in Node.js 14 and above, although partial support was available right from the start. And if you've been tempted to try Dino after my talk last year, it's available in version 1.8 and above. You can detect the support in the browser by checking whether the window.intl object exists. And there's a polyfill if you require it. But I really don't think you'll need it unless you're supporting IE 10 or below. And if you're doing that, well, localization is probably the least of your problems. So here's a quick example to get you excited. So this creates a new DateTimeFormat object, and it sets the locale to an empty array, and that denotes the user's current locale. And there are a couple of date and time formatting options passed, and a format method is called, which is passed a JavaScript date object. Now I'm not passing anything here, so the current date time is used. Now the result will depend on where you are and how you've got your OS and browser configured, but everyone will get a format that they're familiar with, whether they're in the US or the UK or Japan. The first thing you need to do is define which language or languages you want to use. And the API supports every language you can think of. It even supports fictional ones like Klingon and Cornish. But there are a lot of options available for setting scripts, regions and variants. Some of the time you can just pick the language, such as EN for English shown here. But if it's spoken in different places with different dialects and formatting, you should also set a country code. And this is the code for the unrecognisable variation of English they speak in the USA. There's also a second parameter if you want to go wild and specify all sorts of things such as calendars and preferred time periods. But it's unlikely you'll ever need any of these because the starting defaults are very good. Now all INTL object constructors accept a locale object as the first parameter. So you can create one locale object and use it again and again. But it's really not necessary because the constructors will happily use a locale string. And that's what I'm going to be using in all the examples from now on. And if you're using client-side JavaScript, it's even easier because an empty array denotes the user's current locale defined in their OS or browser. Now, I don't know why the JavaScript gods decreed that we should use an empty array, but you just need to know that it works, accept it, never lose faith in their wisdom, and move on. So first, we're going to look at dates and times, which clearly is one of the more useful internationalization options. There's an INTL DateTimeFormat constructor, and you pass it the locale and a second options parameter which controls how dates and times are formatted. And this creates a DateTimeFormat object. Now all INTL API objects use very similar code to this. Now once you have your DateTimeFormat object, you can run various methods, but the one you'll use most of the time is format. And you pass this a JavaScript date object. In this case, I've given it Star Wars Day in 2022. And it returns a string in the US month, day and year format. Now JavaScript's date implementation is a total mess because it was copied from Java in 1995 and they could never update it because it would break all backward web compatibility. Now there's a new temporal alternative coming to JavaScript in the next year or two. It'll be much easier and it's more logical, and I suspect it'll be supported in the INTL API, but that may not happen on day 1, or it may not happen at day 700 for Safari. Anyway, there's no need to keep creating these objects because you can do everything in one line of code if that's your thing. So here's Star Wars Day as a US short date, and the same day as a UK date with the full day and month. But it's still quite a lot of code, but you don't have to write it all yourself because I've created a tool that does all the hard work for you. It's at craigbuckler.com/INTL, and you can set most of the available date and time options, see the result, and copy the generated code snippet into your application. So let's see it in action. Now there are a lot of date and time options, but you'll probably use very few of them. You can set an optional time zone, add a date and a time, and then you can choose the date and time styles. And I've chosen full for both here. And the table shows you what it will look like in various languages and regions. And you can pick one and see the code that generated it. Now if you set the date and time styles to none, you can define your own custom formats. So here I've got a short weekday style, a 2-digit day style, a long month and a 2-digit year style. Now so far we've just used the format method, which returns a string with the current date, but there's also a format range method which returns a concise period range. So in this particular example, it's returning Wednesday the 4th of May 22 from 1:23 AM to 2:23 AM. And it's very concise. Now this is supported in most browsers, but Firefox only received it in August 2021, so be a little wary about older installations. So far we've seen the format and format range methods, which return date time strings. But there are some other methods you might find useful. Format to parts and the appropriately named format range to parts return an array of objects containing name and value pairs, such as the day and the month. And you could use those to create your own strange and wonderful date time formats, or store them in a database, or do whatever you need to do with them. And there's also a resolved options method that returns an object with properties which describes how the format was actually calculated. And variations of all these methods are available in most of the other INTL objects. You probably won't need them very often, but all the documentation is on MDN, and I'm not going to mention them again. The next INTL object we'll look at generates localized relative period strings. And these are things like yesterday and tomorrow and next week in whatever language you need. So there's an INTL relative time format constructor. And into that we pass the locale and another options object as we've seen before. And this creates a relative time format object, which again has a format method. And into that method we pass an integer and a period unit, such as a day, a month or a year. and it returns a string such as tomorrow in US English or mañana in Spanish. And of course, there's a panel in the INTL Code Builder tool that shows it in action. So head over to the tool and choose the relative item from the menu. There are far fewer options here, which is a bit of a relief, but by default, the format method outputs a number such as 1 day ago in English. And if you want the human-friendly alternative, you can set the numeric option to auto, which returns strings such as yesterday. The next item on our localization journey is numbers, and you're likely to use this a lot, of course, when presenting data. And the API includes support for currencies, percentages, and even units for things like times, lengths, volumes, temperatures, disk storage, and more. You should be getting used to the general concept by now. There's an INTL number format constructor, and you pass it the locale and a second options parameter which controls how those numbers will be formatted. And this creates a number format object which again has a format method. And into that format method you pass the number you want to format. And here it is, returned as a string with the number presented in US format, which of course is the same as we use in the UK. But we can generate the same number in German formatting with 2 decimal places. Now notice that the Germans use a dot to separate the thousands and a comma to denote the fraction. And of course there's a panel in the Code Builder tool that shows all this number formatting loveliness. Head over to the tool and choose the unit item from the menu. Now there's a daunting set of options here, but many only apply to specific styles. So you're only going to need the currency symbol if you're defining a currency. Now if we look at decimals alone, we can control the number of digits shown, whether a plus or minus symbol appears, and whether thousands are grouped. And if we change to currency, we can see that we can set the symbol and the style. Now percent has relatively few options because it seems to be the same in all locales. And then there's unit. Now this has dozens of options and only a few are shown in the drop down here, but all will localize into the chosen language. So we get meters spelt properly in British English and then incorrectly in US English. Name localization can generate strings for languages. We call English English, but the French insist on calling it Anglais. Then there are scripts. These are names for written words such as Latin, Braille or Egyptian hieroglyphics. And we have regions. These are country names. We may call it Spain, but the people who live there insist on calling it España. And then there are currencies. We have the British pound, but they like to call it funt sterling in Poland, which sounds sort of more appropriate to me. Okay, so there's a display names constructor which returns a display names object. And that has a method named, any guesses? If you've just shouted format at your screen, well, you're actually wrong. In this case, the method is called of. Now here we're returning the word for the French language as an Italian string. Now why the JavaScript gods decided to use of rather than format is anyone's guess. I am not going to incur their wrath by questioning them. So here's another example which has the name for British pounds converted to Polish. Now, did I add name localization to the code builder? Of course I did. Choose name from the menu and you'll see relatively few naming options. So first we'll look at language. And we'll see how the word English is presented around the world. Then we can try regions and see how the word United States is translated. Then we can look at script and you can see how Egyptian hieroglyphs are written. And finally, we can look at currencies to see how the British pound is portrayed. Now be aware that these lists only contain a small sample of the languages, scripts, regions and currencies available. In some cases there are many hundreds and you'll have to look them up. Next we have list localization, which generates, well, lists. So what it does is create conjunctions. And in English that means there's a comma between each list item and then there's an and before the last one. It can also create disjunctions, which again in English, that's an or before the final item. And it can create unit lists, which is just a comma between items in English, but can be other characters in other locales. Now unfortunately, it won't translate English words in your list into another language. That's a shame, but we developers need something to do. Now you won't be surprised to hear there's a list format constructor which returns a list format object. And we're back to having a format method which takes an array of items and returns that list as a string. Now conjunctions are used by default, so this list in French returns an é. But if we use a disjunction in Portuguese, we get an oo, which is the noise you'll make as soon as you see the code tool in action. Now if you choose List from the menu, you'll see that there's just a few options. It's got some example lists, and you can choose Conjunction, Disjunction, or Unit. And there's also a style which can be set to long, short, or narrow. That rarely does much, but you could see and replaced by an ampersand in some locales. The API can also help with the pluralization of particular quantities. Now this is sort of useful, but you really need to know about the language you're translating into to make any use of it. So there are two options. The first is cardinal, which is the quantity of items which affects the noun you're referring to. And the second is ordinal, which is the ranking of items on the number that's affected. Now both of these return a string, which is either 0, 1, 2, few, many, or other, depending on the locale. Now this can be a little confusing, so we'll look at some examples which relate to English only. If we look at cardinals first, there's a plural rules constructor which returns a plural rules object. Now this has a select method, not format this time, which you pass a number into, and that returns a string. Now in English, the number 1 returns the string 1, which means we don't need to do anything to the noun that we're pluralizing, so like one item. But every other number, except -1, returns other. Now in English, that means we need to append an S character to the noun, so 2 items. If we move on to ordinals, again you pass a number to the select method. And if it returns a string containing 1, that means you can append st to the number because it's the 1st, the 21st, the 31st and so on. But you'll get the string other for 11, because even though that ends in 1, you have to append a th to the number because it's the 11th item. Now most numbers ending in 2 will return 2, apart from 12 that is, and most of those ending in 3 will return few, apart from 13, and everything else returns other. There's a plural menu item on the tool which shows this in action. You just enter a number and choose whether it's a cardinal or an ordinal. And you can see what string identifier is returned for each particular language or locale. But as I said, you really need to know the rules of the language you're translating into to make any sense of this. And I suspect that languages will have some number or noun combinations that don't quite fit into the typical pluralization rules. But it's better than nothing. You'll be pleased to hear this is the final option offered by the INTL API. You probably won't use it that often unless you're sorting or searching for localized words. So in some languages, you may want characters with accents or umlauts to have an equal weight or be greater than or less than another. And the API could also help with sorting numeric strings. So under normal circumstances, a string containing a 2 is greater than a string containing 10 because it starts with a 1 character. So for this, there's the collator constructor, which returns a collator object. And that has a compare method which you pass 2 items into. And it will return a 0 if they're equivalent, a 1 if the first item is greater than the second, or a -1 if the first item is less than the second. And you'll recognise that pattern if you've ever used the array sort method. Now there are several options. So if, for example, you set the sensitivity to base, it normalises the characters and effectively strips them of any accents, so they become equivalent. The tool has a compare menu item, which you can use to see how strings compare against each other. But I suspect you'll only use this if you're doing some very deep localization work, perhaps where you're ordering a table of data that has some non-English characters in it. So I hope you're now wondering how you can apply this INTL API into your own apps. If we consider general server-side programming first, it's a good idea to use some form of tokenization for language settings. Now your client or boss may insist it's English only, but that doesn't mean they won't change their mind later when the business suddenly takes off in Japan. And there's no harm writing functions which convert data, such as numbers, dates, lists, or whatever. And you can do that at the point that they're output. Now, perhaps the first version won't do anything in your app, but it makes it considerably easier to add localization functionality later on. So if your app's written using Node or Dino, you can use the INTL API just as you've seen here. Now, other runtimes have their own localization libraries. They'll be different, but most will have support for dates and numbers. And remember to set the user's locale either by storing a user preference in your app's data store, or perhaps by checking the accept language header, which is a value sent by the browser on every HTTP request. Now clearly, all these options are easier if you add them at the start of your project. Adding them later is considerably more difficult. Now, similar rules apply if your application presentation logic resides on the client. So that's if you're using a JavaScript framework such as, React, Angular, Vue, or Svelte. You can still have browser-based tokenization and string replacement. And of course, you can still have data formatting functions. And it's even easier to use the INTL API because JavaScript's the only language available, and you can pass an empty array as the locale, which sets the user's local settings. Another client-side option is dynamic DOM updates. So presume your HTML has hard-coded dates in US format that you see here. But fortunately, the developer has used a properly formatted time element which has a datetime attribute. Now we can look for all the time elements in the DOM and update them to the user's current locale, perhaps even setting a long format. So let's do that with a JavaScript function which runs as soon as the DOM is loaded. It selects all the time elements on the page, and then it defines a new DateTimeFormat object with the current locale and a long date style. It then converts the node list of time elements into an array and loops through them. And on each of those nodes, it runs the format method and passes a date, and that's been set to the datetime attribute which it found in the time node. Now that returns a localized date string which is set as the content for the node. So if you manage to slow down page loading, you'd initially see dates in US format. But that would then be replaced by a localized version, such as this if you have Spanish settings defined in your OS and browser. Now, of course, the other text isn't translated, but the date is more understandable. And you can do similar DOM updates for numbers and other strings, especially if it's easy to identify them because they use a specific element or a class name. And you could even recurse the whole DOM looking for dates, times, numbers, percentages and currencies, and then translate whatever you find. But just be wary that could trigger some intensive processing, especially on larger pages. It's far more effective to implement localization at the start than trying to address it later. We've covered a lot of localization problems and solutions in this talk. In theory, if you provide your app in every language, you've increased access by 700%. Okay, providing translations for the world's 7,000 odd languages will be a bigger development task than the original app. But the JavaScript Internationalization API can deliver a lot of value, even if you're just sticking with English. Users will get number and date formats that they recognize. It will prevent confusion and possibly reduce your support costs. From a purely capitalist perspective, you have the potential to tap into developing markets that are growing exponentially just as Western markets start to slow down. And it's also the right thing to do from a moral perspective. There's no need to restrict access to your web app just because a user wasn't born in your country. The web is a global network. It can connect people in ways that's never been possible before. As web developers, it's our duty to defend access to the open web. We shouldn't be restricting it through our actions or inactions. Thank you very much for watching this talk. I hope you found it useful, but I really hope you'll adopt the JavaScript Internationalization API in your web projects. There are a few reasons not to. My name's Craig Buckler, and I'm a freelance web developer, and I'm available for hire. You can find my contact links at craigbuckler.com, or you can send me a message on Twitter at craigbuckler. It'd be great to hear from you. Best of luck and au revoir.